Dear professors, colleagues, and scientific people, welcome to my presentation about the design approach of a resilient standalone hybrid AC/DC microgrid of multi-source renewable energy with risk reduction strategy. I'm Kosigan Roland Assilivi, PhD student at CERM, Centre d'excellence régional pour la maîtrise de l'électricité at University of Lomé in Togo. And this work is done with Ama from Addis Ababa University and professors Ajala, Beckley, and Ajavon, respectively from University of Lorraine, Addis Ababa University, and SEM at University of Lomé. This presentation is structured as follows. After the introduction, I will give you an overview of hybrid AC/DC microgrid architecture. Thirdly, I'll focus on microgrid reliability and availability models. And I'll move on point 4 about risk categories, checklists, and assessment methods. And the point 5 concerns strategy and selected risks reduction and grid resilience. And I will end with prospects and risk reduction and conclusion. So let's move on the first point. Electrical energy demand on the rural parts of developing countries is increasing, and consequently, electrification with extension of grids and self-contained microgrids are widely used. So a hybrid AC/DC microgrid architecture is the way forward to provide electric power for residential, commercial, industrial, and public buildings consumers. Besides, extreme events like hurricanes and earthquakes destroy the power grids, facilities, and power generation units. This can result in cascading failures or outage of the entire network with significant consequences. So, research has been focused on hybrid AC/DC microgrids to improve their resilience and reliability. But the starting point for developing and implementing resilience strategies for microgrids is the assessment of the related risks. This being so, our work is design methodology of hybrid AC/DC microgrid in isolated and remote rural areas jointly with a resilience enhancement strategy and proposal of a microcontroller-based architecture for risk cyber reduction, of course, after risks assessments. So this is the overview of hybrid AC/DC microgrid architecture. The black line here is the DC bus, and energy sources like PV panel here in blue and wind turbine in yellow are connected to the DC bus, as well as the battery here in green for energy storage. And the generator here is connected to AC bus in red here. And the two buses, AC bus and DC bus, are tied together by AC/DC bidirectional converter. In this architecture, we have DC consumers and AC consumers tools, respectively connected to DC bus and AC bus. And we have also hybrid AC-DC microgrid, which can be networked. Now have a look on microgrid reliability and availability models. The reliability model of microgrid is evaluated by considering reliability model here and using transition state sampling as shown on equations 2 on and 3, where TTF is time to fail and TTR time to repair. And finally, the reliability analysis is done by calculating SAIFI and SAIDI equation, where the first one is system average interruption frequency index, and the second one, system average interruption direction index. Yeah, as you can see on figure 4, we can change the hybrid AC-DC model to RBD diagram. The availability evaluation equations of hybrid AC-DC microgrid are derived from RBD diagram, which is reliability block diagram. Well, let's not talk about risks. There are many categories of risks, and their checklist is shown on the slide. We have technical, economic, environmental, social, and cyber risks. So this leads us to the risks assessment method, which are decision tree method, which allows modeling of various options for risk response development and also optimizes election of risk mitigation strategies. And you have Monte Carlo simulation, which performs risk assessment using possible models by substituting a range of values for any factor with inherent uncertainty. And you have also Bayesian network method and fuzzy assessment method and fuzzy synthetic evaluation method. Well, now, taking into account the hybrid AC-DC microgrid architecture, reliability and availability models, as well as risks categories, checklists, and assessment methods, and selecting cyber risk in microgrids, which is very significant for us, we propose risk reduction and grid resilience strategy. So on this architecture, we can see many sensors and actuators connected to the strategic point of the microgrid. Here is in green, and we have the energy sources and also the load. On the second one, we propose secure tunnel by virtual private network here in the yellow lines between microcontrollers. This is the microcontrollers installed at strategic points of the microgrid in order to respond to cyber risk on the availability, integrity, safety, and confidentiality aspects. Now, as you can see here on figure 7, We can represent a hybrid AC-DC microgrid as a combination of vertex and edges. So based on the on graphical representation, we can evaluate vertex without redundancy. Yeah, as shown as equation 9, and with redundancy as shown here on equation number 10. And equation 11 here is used to calculate if one or more incidence vertex here, RVI, is converging to a specific vertex. As a final point, according to risk reduction, the proposal made on cyber risk identifier is only a part of the risk issues. It is focused on designing a secure communication tunnel for exchanges of the state information of microgrid elements. But problems of cyber risk also concern frequency control and voltage regulation of AC-DC microgrid under cyber attack. So to conclude, our work is about proposal of a networked hybrid AC-DC microgrid with a wireless sensor network and cyber attack mitigation architecture. The design approach suggests aims to enhance the availability, reliability, safety, and resilience of the hybrid AC-DC microgrid towards specific microgrid's performance and consumer satisfaction. And the proposal on the introduction of wireless sensor networks and cyber security architecture can increase the resilience, availability, and reliability of the hybrid AC-DC microgrid. So that completes my presentation. So thank you for your attention.